You are welcome to Solo for Math, where we make mathematics simple, clear, and enjoyable. This episode, we are going to cover some trigonometrical proof using the knowledge we've so far acquired in trigonometry. Those who haven't, if this is your first video about trigonometry, you can check on the previous videos so that this may make more sense. The links are attached in the description below. Kindly support by sharing, liking, and subscribing if you find this important. All right, let's do some proofs, trigonometrical proofs. We want to prove that A tan theta plus cot theta is equal to 1 over sine theta cos theta. Let's prove this. We are going to prove starting from the left-hand side and aim at getting the right-hand side. So from the left-hand side, we have our tan theta plus cot theta equaling 2. So we simplify this. Since I see that we want to get a sine, we're aiming at a sine and a cos in our expression. So the best step is to change these ones, the 2 into sine and cos. So we know tan theta is the same as sine theta over cos theta, plus cot theta we know it's the same as cos theta over sine theta. So I can get the LCM here. We multiply these two, which gives us sine theta cos theta. When I divide this denominator by cos theta, I get sine theta. I remain with sine theta. Sine theta times sine theta will remain with sine squared theta. Plus, when we divide this by this, we remain with a cos. Cos times this cos that is here will remain with cos squared theta. So from the identities we looked at, we know this identity that sine squared theta plus cos squared theta is equal to a 1. So it means the numerator is 1 over sine theta cos theta. And this is as required here. Part B, another example. We want to prove that sec squared theta minus cosec squared theta is equal to tan squared theta minus cot squared theta. We are proving still from the left-hand side, and we aim at getting the right-hand side. So from the left-hand side, our sec squared theta minus cosec squared theta is equal to, how best can we write this so that we aim at this? So the best is using the identities that we proved. You can remember that there's an identity where 1 plus tan squared theta is equal to a sec squared theta. Then we have an identity 1 plus cot squared theta is equal to cosec squared theta. So I'm going to substitute this. Where there is sec squared theta, I'm going to substitute 1 plus tan squared theta. Where there is cosec, I'm going to substitute this. Why am I using this? Because I see my final expressions have tan and cot. And you see, if I relate the sec and the cosec by this, I'm bringing the tan and cot closer. So when we substitute, where there is sec squared theta, I put 1 plus tan squared theta minus cosec, but cosec is going to be 1 plus cot squared theta. We simplify and we are almost there. This is 1 plus tan squared theta. The minus expands, we end up with -1 minus cot squared theta. And 1 minus 1 disappears. So we remain with a tan squared theta minus a cot squared theta, and this is what is required here. Part C. We want to show or to prove that 1 over tan squared theta plus 1, then plus 1 over cos squared theta plus 1, this is cot, this is equal to 1. We want to prove that it is equal to 1. So we are going to prove so from the left-hand side. The left-hand side. You see the left-hand side, which is 1 over tan squared theta plus 1 over cot squared theta plus 1 is equal to, how best can we simplify this? Using the identities, the three identities we looked at, there's an identity that relates tan with sec. So you remember that tan squared theta plus 1 is sec squared theta. So this, I'll just substitute tan squared theta plus 1 with sec squared theta plus 1 over, we have another identity relating this with cosec. So this will be over cosec squared theta. Now, you know that sec is a reciprocal of cos. Okay? And therefore, cos is also a reciprocal of sec. So it means 1 over sec squared theta is the same as cos squared theta plus the same thing here. Cosec is a reciprocal of sine, and sine is a reciprocal of cosec. So it means it's the same as sine squared theta. And we have an identity that clearly states that cos squared theta plus sine squared theta is equal to a 1. And it is proved. We are successful because the right-hand side was 1 and we've gotten 1. We've proved that. Another example, if we have to prove that 1 minus cos squared theta over sec squared theta minus 1, we want to prove that this is equal to 1 minus sine squared theta. From the left-hand side, our left-hand side, which is this, is equal to, how best can we simplify this? I'm going to work with the identities. Using the first identity we derived about sine and cos, we saw that 1 minus cos squared theta is actually the same as sine squared theta. Then sec squared theta minus sine is the same as tan squared theta. If we try to simplify this, since we need the sign in the final expression, I'll just change this one in terms of sign because the final expression does not have any tan anyway. So the simplest way is to change this into an expression that has sign. So we know that this remains. We are dividing by tan, but tan is the same as sine squared theta over cos squared theta. So on simplifying, this is sine squared theta times cos squared theta over sine squared theta. So the sine reduces with this. So we remain with cos squared theta, but we know this identity from this identity, cos squared theta plus sine squared theta equals to 1. If we make cos squared theta subject, it gives us a 1 minus sine squared theta. So from this, we end up with this. And it's a proven or proved. Another example, I hope you're enjoying. Don't forget to subscribe and to share this content with anyone that may be in need of it. Let's grow this. Let's grow this channel for more content that is important and useful. If we have to prove that sec theta plus cosec theta cot theta equals to sec theta cosec squared theta. This is what we want to prove. Still from the left hand side, it is easier proving from the left hand side. Sec theta plus cosec theta cot theta. This is equal to the easiest. I will do the next step. I will find an expression that relates, or another way of writing sec theta, which is 1 over cos theta, plus another way of writing cosec, it is 1 over sine theta. Another way of writing cot is cos theta over sine theta. And this gives us 1 over cos theta plus, this is cos theta over, this is sine times sine, giving us sine squared theta. If you get the LCM here, it will be a multiple of cos theta times sine squared theta. When we divide cos this denominator by this denominator, this goes remain with sine squared theta times the 1 here. We remain with sine squared theta. We are manipulating fractions. The denominator here, or the LCM, divide by this, the sine squared theta goes, remain with cos theta. So cos theta times cos theta remain with cos squared theta. And this is equal to, we know sine squared theta plus cos squared theta is a 1. We know that identity over cos theta sine squared theta. We are almost there. If we simplify this expression here, we just separate it, 1 over cos theta times 1 over sine squared theta. And we know that 1 over cos theta is the same as sec theta. Times 1 over sine is the same as cosec. So since it is squared, we have cosec squared theta. So this simplified as sec theta cosec squared theta. And that is proved. We look at one more proof. Trigonometrical proof. F. If we want to prove that 1 minus sine theta plus cos theta over 1 minus sine theta is equal to 1 plus sine theta plus cos theta over cos theta. First, pause this video and try to think of the next step that you would take to see that you achieve this. Take a pause. Okay, for me I will prove from the left hand side. And the next step will be, of course, let me not rewrite the left hand side, but for you write it. Left hand side is equal to, I'll rewrite it as this, plus cos theta over 1 minus sine theta. So since I'm eyeing a cos in the denominator here, I see the best step is to multiply the denominator and the numerator by 1 plus a sine theta, and also here in the numerator I multiply with the same 1 plus sine theta. You know, since I've multiplied it in the numerator and the denominator, this does not change the expression. It remains the same. So on expanding, I get a 1 minus sine theta plus cos theta. It's like I've multiplied 1 by all of this, and it gives me this. Now I'm multiplying this throughout. So plus sine times 1, it is sine theta. Sine times negative sine, it is minus sine squared theta. Then sine times cos, it is sine theta cos theta. All of this is over, if you look at this, this is a difference of 2 squares. Okay? So it means I end up with 1 squared minus sine squared theta. When you expand this, it gives you a difference of 2 squares. It gives you this. And we can see that this sine goes with this. And if I take this one and this negative sine, negative sine squared theta, using the other identity that relates cos and sine, 1 minus sine squared theta is the same as cos. Okay, so let's rewrite. It means in the numerator I will have this 1 minus sine squared theta is the same as cos squared theta. We remained here with the cos theta, and here we remained with plus sine theta cos theta over, from one of the identities, this is 1 minus sine squared theta, which is the same as cos squared theta. You realize that in the numerator we have a common factor, which is cos. So when I take it out, let me write in the next. So we had cos squared theta plus cos theta plus sine theta cos theta over cos squared theta. So we want to factorize out the common factor. You see that cos theta is common in the numerator. So here we remain with cos theta plus this remains a 1 plus this remains sine theta over cos squared theta. So this reduces this, so we remain with only cos theta, and in the numerator we shall just rearrange to have an expression looking exactly as what is required. will remain with this in the numerator, over in the denominator will remain with cos theta. Remember, this reduces this to 1. Okay, reduces this to only 1 cos theta. And this is what we have on the right hand side. You can try out more proofs, and if you find any challenging and you would want us to try it here, to try it for you, to do it for you, to explain it for you, kindly share it with us in the comment section. Thank you for watching. Don't forget to like, to comment, to share, and to subscribe. Bye-bye.